This Module 9 skills test is about parallax, and parallax is just a way of determining the distance to stars, and they have to be relatively nearby stars, but it's a method. And what you see is initially you see an animated image, and here's just a freeze frame of it, where you see the position of the Earth. Let me change my color. You see the position of the Earth with respect to the Sun at different times of the year. You also see a nearby star, and then you see this grouping of background stars. And the first question is, you need to determine, okay, where would the nearby star appear to be with respect to these background stars? So that winds up being question 1, where you just choose location 1, 2, 3, or 4 at 2 different times of the year, January and July. Okay. Then in question 2, you're given a star and its position among the background stars over a course of several months. In fact, it starts out in like July 2000, and it runs for about a year, it looks like, of motion. And so you're going to watch that cycle through a few times, and then you have to take into consideration that 2 of the stars in that star field are separated by a half an arc second. So from here to here is a half an arc second. And so you have to estimate, okay, what is the range of motion for the star that is in motion? If this, between my orange, if that's a half an arc second, then what's the range of motion for the moving star? And you got several choices. Now notice in question 3, I don't have the freeze frame of it, but in question 3, whatever the angular separation that you came up with in question 2, notice that the parallax angle is half of that value. So whatever you answered in 2, cut that in half. And then what you have to do is you have to then do the reciprocal of that value. So for example, let's just say that the I'm not going to use one of the numbers in here. Let's say that your answer to number 2 was 1/8. Then in question 3, you need to first of all cut that in half. So 1/8 cut in half is 1/16. And then when you take the reciprocal of 1/16, that winds up being 16. It would be a star that's 16 parsecs away. Okay, so that's the way you are going to work question number 3. All right, moving on to question number 4. Notice in question number 4, you're given absolute, it's a graph of spectral type, which is essentially just a way of saying temperature of a star, versus its absolute magnitude. Again, the other skills test in this module deals with absolute and apparent magnitude. If you're not familiar with those terms, become familiar with them, either in your book or by doing the other skills test. So what you need to do in question 4 is essentially just estimate what the absolute magnitude is of these various stars. So notice that one of the stars is an A7. So you have to determine an A7, where would that be along your x-axis here? Then you would go up and you would hit, let's just say it's right there, and then you would slide over there and get a value for your absolute magnitude. In question 5, you do sort of a similar thing, but here you're given a table of apparent magnitude, and you're asked, oops, take that back, here we go. You're given a table of apparent magnitude, spectral type, and distance. And so we need to determine whether or not your star is much closer than 10 parsecs, around 10 parsecs, or much farther than 10 parsecs, according to its apparent magnitude and what you know of the absolute magnitude from the previous question.